My group is studying the spread of crop diseases, how the spread can be managed, and what methods might be used uh, to deal with that, how to find out what crop diseases occur in each crop, and what remedial methods might be taken. So I will go ahead and turn it over to them. Aksh, Eashan, and the rest of the crew, um, go ahead and step up and make your presentation.
All right. My name is Eashan, and I'm part of Dr. McMahan's group, MLC, and we're utilizing CNNs to predict and track the spread of crop diseases. This project's by Aksh, Akshay, Anya, Naren, Raman, and Sophie.
So, the main problem that we noticed as a group when we were creating this project was specifically related to the proliferation of crop diseases, in that it is, especially nowadays, spreading extremely quickly across plantations and farms through wind, rain, and soil. And it's been spreading extremely fast, and the identification of these disease crops has now become extremely challenging because there's so many of them that are grown commercially that it is just very difficult to keep track of statistically, as well as like in data sets, etc. And if the crop diseases are not properly identified and cured, then they may have the potential to the diseases themselves have the potential to destroy countless acres of farmland. And this is extremely detrimental to crops as a whole, as shown in a recent statistic by the U.S. government that stated that 20 to 40% of agriculture die every single year due to disease and other pesticides.
Okay, so as a group, we also looked into some previous solutions, and so most of these research projects that we found that were similar to ours had a very similar program idea, and then that will screen through images while also like sticking to a certain crop to diagnose. But unlike these projects, we wanted to collect our own data using our own hardware device and also like focus on a wider variety of crops.
Our solution is that we plan on building a remote controlled shredded vehicle that can go around in any terrain, ideally farms, mountains, and it goes around gathering data of plots of land in order to identify trends in geographic locations and plant diseases. Our hope is that this facilitates actions already taken by officials from the USDA's Animal and Plant Health Inspection Service and eventually becomes more efficient than it. The issue with them is that it takes a little too much time for farmers to identify the disease, and by then a lot of time it's too late, and as such they lose on a lot of revenue and a lot of their crops end up going away as well. As said, this solution would aid farmers in directing their efforts into taking special action for a targeted plot of land and prevent the spread to the rest of the crop. As for the software side, we're utilizing a CNN, a convolutional neural network, for disease recognition. What a CNN is, it's a regularized type of neural network, well suited for image recognition and processing tasks. It excels in utilizing multiple of its layers, specifically its convolutional layers. It allows it to filter through the images we provide it and extract the most important details from it. We took this data set from Mendeley data, and we're starting out with the cashew data set. It gives us 4 data sets of 4 crops: maize, tomato, cashews, and wheat. Utilizing Google Colab, we're in the process of right now designing the CNN. Once we've finished the CNN for cashews, we're going to add on to adding maize disease recognition into the models as well. Libraries that we're using are TensorFlow, OpenCV, Matplotlib, and NumPy.
Okay, so the current design that we have planned out for the hardware of this project is to use a treaded vehicle. So far we have CAD modeled our treaded vehicle chassis in a software called Onshape. And then we also plan on 3D printing out this chassis out of a durable material such as nylon to make sure that it can survive different terrains and harsh environmental conditions. Inside this chassis, we plan on using a Raspberry Pi 4 for our data processing and using our algorithm, while also using a Pi camera for data input. We plan to move this treaded vehicle using two high torque DC motors paired with a H-bridge motor controller, which will also be paired with a receiver to make the vehicle remotely controllable. After all these parts are assembled and put together, we're looking at a price of somewhere between $70 to $90 per unit.
So as for our future goals, so currently our data sets and our entire engineering model relies specifically on pictures for the CNN to run on like the software. However, although this is very important, in certain cases, like a dilemma that's being diagnosed might not be related to a disease. It could be a malfunction in, not a malfunction, but like a malnutrition problem, maybe like low water supply, or maybe like very like the slow degradation of soil, and probably like a fertilizer is required. So we're planning on adding moisture sensors, pH sensors like acidity, and specific chemical sensors like phosphate, and also humidity sensors, because sometimes if we're looking for a disease, it might not be a disease that's the problem, but it could be a nutrition that's the problem. So to sort of make our device more compatible with like real life situations, we're planning on adding like these other added sensors. Also, we're currently experimenting and designing a new approach to gathering data on specific chemicals. So instead of having like multiple different sensors for like phosphate and like calcium and like all these other different chemicals, what we could do instead is we could use spectroscopy. So in that, what we would do is based on like the emission spectrums emitted by a plant, we can determine like the intensity of these emission spectrums can help us determine different chemicals and different a number of chemicals, meaning that, like for example, on the graph on the left, a higher intensity or a higher amplitude would basically mean that there's a higher number of these chemicals, and proportions of different chemicals with respect to these different emission spectrums can help us determine more about the disease and how it targets different chemicals. And also regarding like future goals that we're also trying to cover. So autonomous driving is also a very important factor, because remote control can be efficient in some situations, but it would require a lot of heavy sort of maintenance and like control by like the owner of the car, the vehicle. And we also want to gain like a larger quantity of data from more like different crop fields to increase the accuracy of the prediction software, because this would make it more efficient compared to you like gather like in binomial means. Currently what happens is samples are taken from farms and then brought to labs. They're tested separately in different chemicals, and then they're brought back with the results. Instead, what we're planning on doing is using the same CNN and the same sensors, we could determine the different sort of diseases and problems going on in crop fields, so it would be more accurate and more efficient. At the same time, we want to be able to extrapolate the ideas of this invention to other crops by having different data sets and new data sets.
And we just wanted to also acknowledge and thank Dr. McMahan and Professor Downing as well for providing support throughout the research process.